Hey QD Coders, this is Michael. I'm here with the Jinaga State of the Union. I recently went through Jinaga.net with some of my fellow coworkers, my fellow improvers, and we built a Jinaga model in Polyglot Notebooks, and then we implemented that model in a MAUI application. So I just wanted to walk through that example with you as a way of showing you the current state of Jinaga.net. So let's get started with a .NET Polyglot Notebook. So I've got my Polyglot Notebook extension installed, so I'm going to use that to create a new blank notebook. And I like to use the format IPYNB. A C# notebook. And let's start with some markdown so that we can describe what it is that we're doing here. We're building the CoLab, which is a collaborative lab project app. So the neat thing about doing this is that you can write all of your user stories and your documentation right alongside your code while you're building things up. So in order to make sure that we can use Jinaga.net inside of reactive Polyglot Notebooks, let's go ahead and #R to reference a NuGet package called Jinaga, and another one called Jinaga Graph Viz. Now it's installing those applications, those packages, and then once we've got those installed, let's create another code block here so that we can do using Jinaga and using Jinaga.graphviz and bring that into our current namespace. Okay, so as I've discovered with the class, you have to actually have GraphViz installed. The Jinaga.graphviz package is supposed to ship with a copy of GraphViz, but for some reason it doesn't actually call that version. It tries to find the one that you've got installed on your machine. So if you don't yet have GraphViz installed, you should be able to get that installed for your operating system such that you can type dot at your command line and then run the GraphViz compiler. But once you've got that, then you can come in here and you can start to describe your application. So we want to be able to create projects. So I'll do a second level heading here. And so let's describe what we can do with projects. A user can create projects. A user can name projects. A user can delete a project. And if a mistake was made, a user can restore a deleted project. So those are the 4 user stories, use cases if you will, that we want to implement. The next thing I want to do is actually write a Jinaga model using some facts to represent those 4 particular operations. So a user can create a project. So let's create a fact type called project. And in fact, I like to use the name of the application as sort of a namespace of the fact type. So a CoLab project, that is going to be a record of type project, and the user can create the project. So that means that we're going to have user creator, and then we're going to record the time at which they created that project. So we're going to have a date time created at. So that is our CoLab project, and we're following a pattern here. You'll see I'll make some decisions here that I might not you might not fully understand from what we're trying to accomplish up here, but these are following a pattern that I've discovered works pretty well for this kind of application. So that's the fact that records that a user has created a project. Now I want to record the fact that a user can name the project. So we've got a fact type, and here I'll call it colab.project.name. So we're setting the name of the project, and so the convention that I like to use is that fully qualified namespace with the property attached to the entity that it is associated with. So this is a record we'll call project name, And the pattern that we're going to follow here is that it names a particular project, and we've got a string value, and then we're going to have an array of prior project names. Project name array prior. And that's the pattern for a mutable property. So that tells us that we can create new project names that replace previous project names. Notice we don't have a date time associated with the change of a property. It's not necessary for mutable properties. In fact, it just gets in the way. So we've got 2 out of the 4 recorded as fact. Let's do another fact type to record that a user can delete a project. So we'll do fact type collab project.delete. That's the convention that I like to use. So this is a record, project delete, and this is for a particular project. And we also need to record the date time deleted at. So this is following the delete pattern. And so the delete pattern, just like the create pattern, needs to capture that date time. The reason will become apparent as we get a little bit deeper into the model. Now, the last one, if a mistake was made, the user can restore a deleted project. So we want to do a fact type, and the pattern I like to use here is collab project restore. And this is a record of project restore, and the thing that we restore, we attach the restore to the deletion itself. So we follow up the project delete, and here we don't have the date time. We just do the project delete, and that is the pattern that I like to use there. So these 4 facts correspond with these 4 use cases. So let's go ahead and render out those facts. We want to render those types because that's all we've got right now are those fact types. So we want the type of project, and we want the type of project name, project delete, and project restore. And I won't use a semicolon at the end of this line because I want it to render the result. So show me the result. Type for namespace data time. Okay, how about a date time? There we go. Show me the results. And now I've got this graph that shows me exactly what I can do with a project. So this graph, I should be able to tie back to these user stories and completely understand what's going on. So a Jinaga user, somebody who decides to log into the application. Then we've got a Colab project. The creator is the user. Then we can set the Colab project name. So we set the name of a certain project, and we can replace prior names. Then we've got the Colab project delete. That can delete a project. And then you can restore, taking away the deletion of a project. So this is the model, and we can document that model inside of a Polyglot notebook that lets us describe how this application works. Okay, so now I want to go ahead and exercise this model. So the very next thing is we do a var j equals Jinaga client.create. So now I have an instance of j. Let's run that. I'm just hitting Control Enter in order to run. I could hit the button, or I can play and put the results below. Same thing. So I've got my Jinaga instance. Let's go ahead and record some facts. So I'm going to, first of all, represent the Jinaga user. So I'm going to await j.fact new user. And we can see that a user takes a public key. Now, this isn't going to be a real public key, but the public keys that it actually generates look a little bit like this. So we'll kind of fake it. So we'll say public key, and we'll have some text in there. I'll just put my name, and then we'll say end public key, and that will be my Jinaga user. Now, the user can create a project. So now that we've got a user, let's create that project. So I will call this project Alpha. You can tell what podcast I just listened to. So we're going to create a new project, and it says here, I need to know the creator. That was Michael. And I need to know the created at. So I'll use date time.now. I could also use UTC now. As we'll see, it won't matter which one I choose. So I'll just say now. And then I can give it a name. So var alpha name equals await j.fact new project name. And so now I need to know the project. That's alpha. And the value is the string alpha. And the prior project names, well, that's got to be empty because this is the first one. So let's say a new project name array of length 0. Okay. So that is my my first set of facts. Let's go ahead and render those out so we can see those. So I'll do a render fact, and we'll have Michael and alpha name. Again, no semicolon because I want the output to just appear right here. And this is what I've got. So here's the public key. Here is the project created at 8:27 and 23:31 Zulu. So no matter what time zone I use to create the fact, it's always going to be converted into UTC. So it doesn't matter if I use now or UTC now. It comes up with the same result. And then we've got the project name Alpha. Very good. So I'm continuing along. I'm using Markdown to describe how this model works and what you can capture. But then I'm also using code in order to demonstrate specific facts within this model. So now I want to get a list of all of the projects that a certain person has created. So let's go ahead and create another code block, and we will first write a specification for projects by user. So this will say, given a user, I want to match some specification. So this is going to be the user that I was just given, and then the facts repository. And now in here, I can write the syntax for projects by user. For this, I'm going to go ahead and use the link syntax that looks a bit like SQL. So you can use extension methods. It all produces the same thing. But I'll just say from project in facts of type project. So that gets me the projects. I want to now just get the ones by this particular user, where project.creator is equal to user. Then I'll select the project. Okay. All right. Sometimes it doesn't catch up. Right. Yeah, it's not caught up with the fact that I do have a select clause. So now let's go ahead and run that query. So I'm going to get the projects. That's going to be equal to await j.query. And so first of all, I say the specification, projects by user, and then the given fact, which was the user, Michael. So I just run that specification. I can provide a cancellation token, but it's optional. And once I've got that, I can go ahead and take a look at all of the projects. That should be the collection of projects. So again, no semicolon, so that I can run this, and I see an array of projects. So there's my project, created at 8:27:23:31. That project right there. Very good. Now I want to get the project name, so let's go ahead and create an anonymous object here. So I've got the project, but then I've got the names. And for that, I will have another specification right here. From name in facts of type project name, where name.project is equal to project here I just want to select name.value. So this will just give me back that list of strings. So run that, and now I've got this array that has the project, that's the actual fact that we just looked at, but then the array of strings. This is just the array containing alpha. Okay, so this is starting to look good. Let's play around with this model a little bit. Let's suppose that I wanted to change the name of the project. So let's come in here, create another code block, and let's change it from Project Alpha to Project Beta. So var beta name is equal to, I want to do a await j.fact new project name. So now here I'm giving it the project. So alpha is the variable that actually holds the project, even though it can have a different name. That's the name of the variable. But here the name that I'm going to give that project is beta. And I need to provide the array of prior project names. So that is alpha name. So that should understand. Okay, maybe it doesn't. Project name array alpha. I think you'll be able to figure it out. Okay, so we can create the new project name. Boom, okay, that worked. And now if I run this, I should see that new project name show up. So let's run it. And I see, all right, here's the project. But it's got two names, alpha and beta. Why is that? Well, that's because right here, I told it to give me all of the project names throughout history. I didn't tell it to give me just the project names that have not been replaced. In order to say that, I want to say where not exists, fact.any project name that I'll call next, such that next.prior contains name. And this is the facts array. So there are not any facts of type project name that are the next fact after this current one. So its prior collection contains this current name. Let's see if we can understand what that means real quick. So let me do a renderer, render facts, and I want to have all of these. But then I also want to have beta name. Okay. So this is the graph that I end up with. Here's the project. I've got the name alpha, and then I've got the name beta that refers to that project, and its prior is alpha. So if I were to run this and I get back alpha and beta, for alpha there exists a fact prior of a fact name. This one happens to be beta, where next prior, that arrow there, contains alpha. Since that exists, then we know that it has been replaced. So this is the pattern for getting the most recent version of a mutable property. And so when I run that, I'll see that's exactly what happens. I've got the value beta. Okay. So we're starting to see a little bit of the pattern emerge. Now let's take a look at the next part of the pattern, the part where we can delete a project. So let's come in here, and I want to be able to delete a project. So let's create a, we'll call it alpha delete even though the project is no longer named alpha. Alpha is still the name of the variable. So that's going to be await j.fact new project delete. And the project variable is alpha. And the deleted time is date time now. The project is deleted, which means that I should be able to see that project delete. Here's a neat little trick with renderer, render facts. If I say alpha delete all by itself, it'll still show me all of its predecessors. So it still follows the tree all the way up, or the graph. So here I'm just not rendering out the names. We've seen that in this other graph. They're still there, but here we're just concerned with the project delete. So we've got this fact that says that this project has been deleted. We know that it was deleted at 23:41, almost exactly 10 minutes later. And so I want to make sure that the projects by user does not contain this fact anymore, this project. Well, it still does. Why is that? Well, it's because right here I did not say and no facts any project delete. We'll call this delete, where delete.project is equal to the project. Okay, so if there are no project deletes, then it will show up, but once a project delete is created, it'll disappear. Let's see, and indeed, we get an empty set. Doing very well. But that's only 3 of the use cases. I still have 1 more use case to test out. I need to be able to restore a deleted project. Let's add some code. Var restore is equal to await j.fact new project restore. And what does this take? It takes the project delete. So that is called alpha delete. So we create that. Let's render out that restore fact just so that we can see it. And here we have Colab project restore that restores this deletion. No properties, no date time associated with it, nothing at all. Just the mere fact that this exists tells us that this deletion should not be honored anymore. Now, of course, we are still honoring it because we have to tell it and not facts.any project restore such that restore.delete is equal to delete. And that should bring it back for us. And there we go. Now it's back. So we can create a project, we can name a project, we can delete it, we can restore it. This is the specification that we end up with that implements all 4 of those use cases. And here is the model that encodes all those 4 use cases as facts. So this is how we can develop a model inside of .NET Polyglot Notebooks. Now, I would like to implement this model within a MAUI application. So I am going to come over to Visual Studio, And I am going to create a brand new project. We're going to do a .NET MAUI application. And inside of Jinaga samples, I will call this Collab MAUI. Oops. There we go. Let's use .NET 7 so that we get the very latest MAUI. And now we've created a brand new project. If we were to run it, we would see exactly how that works. So let me first switch to the Pixel 5 emulator. This will help me to demonstrate that that this is all working on a mobile platform. And so the application starts up, and we see the example application that ships with the template. Just counts the number of times that you click a button. Very good. Let's turn this app into Collab. All right, we can start with the main page. We can see that we've got a scroll view that has some stuff in there that data binds this button. Actually, this doesn't use data binding, it just updates the button text. We're going to want to get rid of all of that. Okay. And instead, we want to data bind this view to a view model. We can see right now it's keeping track of the count. We don't care about that. We've got our counter clicked. We don't care about that. Let's go ahead and start from scratch and data bind this to a view model. I will create a new class that we will call we'll call it the main page view model. And so we've got a main page view model. I want to use an MVVM library in order to make this bindable. The MVVM library that I shall use is the Community Toolkit MVVM library. So look for Community Toolkit MVVM and install that. And once you have that, then you should be able to come into your view model and say this is an observable object. Control dot, and now you can bring in using Community Toolkit MVVM component model. Very good. And now I have an observable property that is the property for this private field that I'm about to implement. So private observable collection of, and these are going to be the projects. So I'll say project view model and call that projects with a lowercase p. Now, this type doesn't exist yet, but I want to go ahead and implement that type. Also, it's complaining that we are not in a partial class. Once I have observable properties, I need to make this partial. And now it can generate the code for that observable property in the other half of the class. Control RG, get rid of all those unnecessary usings. Looking nice and tight. Okay, let's create the project view model in a new file. Navigate there, and I want this one to be an observable object. And this, at the moment, just has the one property, the name. So we'll make that an observable property, private string name. we'll go ahead and initialize that to uninitialized. That'll help us to diagnose any issues that come up. Once you're happy with this, you can change that to an empty string. But now we have to make that partial so that it brings in that property. So now I've got my view models. So this is my main view model, has a list of projects. This is a project view model, has a name. And so in my main page, I want to create my main page view model and set that up. So I'm going to say right here, private main page view model. I'll go ahead and create that here. Call that view model. View model. And then I'll override on appearing so that I can say the binding context is equal to the view model. And I want to call view model dot initialize, which doesn't exist yet, but I'm going to want to initialize the view model when it appears and then uninitialize on disappearing. Okay, so I'm going to be able to call those two things on that class. Let's go ahead and generate initialize, generate uninitialize, and let's see what we're going to do. This is where I'm going to want to run some Jinaga specification code. So let's go ahead and add a reference to Jinaga. There we go. Add that reference. And now inside of my main page view model, I can actually create a Jinaga specification. So that's going to be precisely the specification that we set up here. Da-da-da. Projects by user. Okay, so we have our specification. Oh, but we don't have any of these model objects. Let's go ahead and bring that in. I'm going to create a new class called model. Now here I don't actually need the model class, but what I do need are all of these facts. So let's bring those in. So you can see that brought in the reference to Jinaga. So now I've got my Jinaga model. So over here, now it can see the model. Everything is good there. So next I want to, here I want to actually get all the projects, but I'm not going to use j.query inside of my MAUI application because that only gets the projects once. What I really want to do is keep that specification alive. And so as new projects are added, I want them to show up in the user interface. So I'm not going to use j.query, I'm going to use j.watch. But if I try to do that, it says, I don't know what that is. We need to actually create our Jinaga instance. So let's go ahead and create a new class called Jinaga config. And so this will be a static class that has a public static Jinaga client called J. And so for that, I'm just going to say Jinaga client dot create. And now I've got my instance of Jinaga. And so then here I can say Jinaga client.j. Or not Jinaga client, Jinaga config.j. Now I've got all those methods. So I can do watch, and I can watch the specification, projects by user. I can start at a given fact. I'll start at the fact of Michael. And then I've got an action to perform whenever I see a new projection. So I need to know what that starting fact Michael is. For right now, I will just use exactly this fact here. So let's just take this inside portion, and we will use that as our parameter. So I'm not calling j.fact here because I don't want to actually create that user. I just want that user to be the parameter that I use for this watch. So then once I've got a projection, that projection gives me the project and a queryable of type string for the names. So let's go ahead and create the project view model. So that's going to be a new project view model. And then I want to add that project view model to my collection of projects. So I've initialized that observable collection here, but it's an observable property, so I should use the property every time I'm accessing it. So projects with a capital P dot add the project view model. Okay, so now that's in the array of projects. And then if it gets removed, I want to remove it from that list of projects. So I'm going to return another lambda, and this one is going to say projects.remove project view model. So when it's added, it'll call this lambda, and then when it's removed, it'll recall the lambda that this one returns. So that will add and remove projects from this view model collection. And now there's one other thing that I want to do. I want to actually set the project name. So let's take a look at project view model dot name. Not the project view model dot name, sorry. I've got the projection. That's got dot names, which right now is an iQueryable of string. So iQueryable's got some nice useful methods in it, but it doesn't have the one that I'm looking for. What I want this to be is an observable, so that I can then respond to it when things change. So to make that happen, I'm going to say facts.observable. Wrap that around my iQueryable, and that gives me this nice little thing called onAdded. So when the name is added, I can set the project view model dot name equal to that particular value. That comes in as a string because that's what I selected. So this little bit of code right here should update my view models as projects show up from the data. And now that we've got our view model bound to our specification, we need to get all of the data into this application. So how are we going to do that? Well, if we come back to here, we've got all these j.facts. Of course, we could bring those into the mobile application. And in fact, we will eventually. As the user interacts with the application, this is how they'll create a new project. This is how they will change the name of a project. So those will make it into the application soon enough. But for right now, what I want to do is connect the application to a backend. And so the way that I'm going to do that is I'm going to go up to dev.jinaga.com, and I'll get logged in using my GitHub credentials, and then I'll be able to create replicators of my own. So let's go ahead and create a new replicator. So this was the collab for improving you, and we're going to create this in development. So when you create a replicator, you get this URL. So this is the address of your backend. We're going to go ahead and publish so that the address becomes live and we can actually hit that address. And then let's copy it, and let's first set it up on the notebook. So when we do Jinaga client.create, we can send in a lambda called options that then lets us set various options, such as the HTTP endpoint. So that's going to be a new URI, and we will paste in that replicator endpoint. So that gives us the access to the replicator, and now everything that I do in this Jinaga client is going to be uploaded to that endpoint. So I'll go ahead and create the project, or I'll create the endpoint, and then I will create the project. So there's our project. Now this one was created at 8/28/0032. I paused for dinner. And then let's go ahead and, yeah, it's named alpha. So let's see if we can pull that information down from this, this endpoint and into the mobile application. So I'll come back to the mobile application, and we will go back to Jinaga config, and then right here we will do the same thing as we did here. We've got options, and we're going to set the HTTP endpoint to the replicator endpoint. Okay, set that. And now this application is connected to that backend. I didn't have to make an API, I didn't have to set up a database, add tables, migrations, any of that stuff. I just create a replicator and hook it up. So if everything is good, then I should have my replicator here and it's published. I have uploaded these facts to that replicator. And then in here, I am connecting to that replicator and pulling those facts into my main page view model. So now I want to bind those facts to the user interface. So let's come back to this XAML. Now I've already set the view model as my binding context, so that means I should be able to create in here a list view where the items source is equal to binding projects. So that should be all the items in my list view, and then I want to set the list view dot item template to a data template. So each item in this list view is going to be represented by a label, and I'll set the font size to large. That way we can see it nice and big on the screen. And let's set the text equal to binding. This is going to be the name of the project. There we go. So item source projects. If I take a look at my project view model, not my project view model, my main page view model, that is this observable property. Of course, it ends up with the capital P. There it is, capital P projects, when I expose that as an observable property. And then each project is a project view model that has a name observable property. So let's data bind that name. So now with all of this, this should pull down the information from the replicator, bind it to that view model, and display it on the view. And that all happens because initialize calls j.watch. And I'll come back here and I'll implement uninitialize later. But first of all, we've spent long enough. Let's see this thing work. Start it up on the Pixel 5, and it loads. Then it should hit that back end, and after it brings in all the application data, it should show it on the screen. It is not showing it on the screen. There might have been a problem. Let's go ahead and add a little bit of diagnostics to see if we can figure out what the problem is. Okay. When we call j.watch, it returned something called an observer. Well, I want to make this a field. So I will generate a field for iObservable. So there's my observer. So now that I've got the observer, uninitialize will let me do this. I can call stop on the observer. I also have things like refresh, so I can initiate a refresh of my specification. But then here I've got these two properties here, cached and loaded. I can await those properties. Those are tasks, and that will tell me when the watch is finished, and it will also throw an exception if there was an error in the backend. To make all of that work, I'm going to create a new observable property backed by this private string message, and the message will start out as loading. So then after I call initialize, I will call a private method called monitor. Let's go ahead and set that up. This is going to be an async void because initialize isn't going to await anything. It's not an async method. So since I made this async void, then I absolutely must handle exceptions myself, because I know that there's nothing that this is going to throw to. But fortunately, this is exactly what I wanted the monitor for, so that I can await these exceptions. So I'm going to await observer loaded, and then when it's ready, I'm going to set message equal to loaded projects. But if there's an exception, then I'll set message equal to ex.message, and then it can see what went wrong. So that's my little monitor method that's going to set the message whenever something is finished happening. So perfect. Now I want to data bind the message to the view. So let's go back to the main page XAML, and let's do that inside of the content page. So I'm going to set up a grid so that I can put the scroll view inside of the grid, and I'm also going to put a label with the font size of header, and this text is going to be binding to the message. So I'll put that in there, and so I'll have these two things inside of my grid. So let's set my grid row definitions to a row definition with the height equal to auto for the message, and a row definition where the height is equal to star, fill up all the space for the scroll view. So this one is at grid row 0, and the scroll view is at grid row 1. Okay. So this should show that message on the screen, and that will tell me what it is that went wrong. All right, we're loading. specified cast is not valid. Well, I wish you would tell me what the specified cast was. Okay. Very interesting. What is it trying to cast? Okay, I've got facts.observable for the names. Got the project name. Next prior contains name. Okay, let's just see if it's able to make it this far. So stop it and start it again. Okay, it does make it this far. So I can create a project view model. Perfect. I can add the projects. Nope, that's where it throws the exception. Adding the project to the main page view model. And that's because observable collection project view model. What I often see is that when you add something to an observable collection and it's data bound, it immediately tries to access it. So it immediately grabs the properties of that project view model. So here inside of the project view model, we can see we've got two of them. Here's the class that I wrote, and here is the class that was generated. So public string name. This is doing the onProperty changed and all that data binding stuff. So what it might be doing is doing a cast for this main page. Label, font size, text, binding, name. Item source is projects. What is the issue here? List view, item source, item template is a data template. Ah, I forgot one layer here. That's a very strange error message to tell me that it's missing a view cell. Now that it's got the view cell, it should be able to show the project to me. So starts up, it fetches the project from the back end and hits the breakpoint. So now it's creating the project view model, adding that to the projects. Now it's data binding to it. Boom. All right, that's data bound. And now it shows, oh, it doesn't show anything on the view yet because it's paused, I guess. Okay. It's going to set up the unadded collection, or the unadded subscription. Let me go ahead and set a breakpoint inside of here so we can see that happening. So it's going to skip over that, return the remove method, but then it'll come back through and it'll say, here is the name of the project. This is project alpha. So set that up, and we've got loaded projects alpha. Perfect. Okay. So project alpha is on the screen. We don't need these breakpoints anymore. Let's do a little bit more on the application. So we saw that we were getting back an observer, and we could do things like monitor the observer, and we could stop the observer. Let's do a refresh. So I'll come back to the main page XAML, and let's add another row definition here at the bottom. This one also is going to be auto. So inside of this one, I can do a horizontal stack layout, grid.row2. That way I can put a bunch of buttons in this horizontal stack layout. So let me do a button that I'm going to set the equal to refresh. And if I do this, I should immediately see the refresh button show up. It's kind of shoved in the corner. Let me set the margin around that. So a nice little 10 pixel margin, push that away from the edge. MAUI has this little auto reload, this hot reload feature. Works pretty well. Now I want to bind refresh to a command inside of my project view model. Not project view model, main view model. So let's set up the command. So I'm going to have, next to my observable properties, I'm going to have a public command. This is going to be my refresh command. And so I will set that as a getter only property. That way inside of my constructor I can set refresh equal to a new, this is going to be a relay command. That comes from the community MVVM toolkit, and I pass in the name of an action. I'm just going to give it the name of a method that I will generate here. Generate a method, handle refresh. Okay, there's my method. So I'm going to put that right here. So you've got the observer. Just call refresh on the observer. So now I should be able to, well, let me do one more thing. Let me set the message equal to refreshing, and then call refresh. So now I should see. Let's see. Oh, I need to data bind it. Haha. So main page XAML. Let's go ahead and set the command equal to binding refresh. And so when I hit refresh, I should see it toggle. This might require a rebuild. Let's just double check everything. It sets the message to refreshing, calls the observer. And this is the command, relay command. Okay, let's go ahead and reload it just to make sure. All right, we load. We've got alpha, hit refresh. It says refreshing. And let's see. Yeah, I need to monitor again, don't I? Yeah, because monitor already did its thing here. It awaited, and then it said that it loaded the projects. So, well, let's come back here and call monitor. And now, when I hit refresh, okay, maybe the hot reload isn't working with the code like that, but we'll get it. Refresh. Maybe it's just really happening that fast. Well, let's try this out. Refresh. It hits monitor. This checks observer loaded. Huh. Oh, wait a minute. Okay. Okay. I forgot about this. Refresh is a task returning method. You can't just trigger a refresh, you have to await the refresh. That means we want this to be an async task, handle refresh. So I await the observer, and then I say message is refreshed projects. And I can do my try catch around this, and I can set the message equal to ex.message. Okay, so now this is an async task, which means we can't use relay command anymore. We have to use async relay command. Okay, now that can call an async task. All right, so let's restart it. Loaded projects, it says uninitialized. Oh, that's interesting. That is really interesting. Let's hit refresh. Refreshing, refreshed projects. Still says uninitialized. That is very strange. Let's see if refresh will call my onadded. Actually, yeah, refresh isn't going to call anything here because there's nothing new on the replicator. But let's try these 2 breakpoints, and let's just restart the application, see if these 2 breakpoints get hit. Yeah, we get the first one. We do get the second one. So it's got project alpha, and then I refresh and nothing new. Very interesting. Okay, that might still be a lingering Jinaga.net bug. Alright, I will see if I can track that down. In the meantime, there's something else that we did over here that I want to make sure that works within the application. What we did here is we updated the name. We set the name to beta. So let me run that code, and that way it creates the beta name for the correct project and updates it, uploads it to the replicator. So now when I hit refresh, it pulls down the new name, and we see it on the screen. Okay, so we have a MAUI application that's connected to a replicator as the backend. Oh, what about deleting the project? Let's try that out. Let's do the delete. And now when I refresh, project goes away. Perfect. And that's because it called this line right here. Very nice. Now let's restore the project. Boom. We've uploaded the restore fact to the replicator, and now when I refresh, the project is back. Excellent. Okay. Now we've got a fully functional MAUI application connected to a replicator. Still some defects to work through, but that is the current state of Jinaga.net and the replicator as a service. So please check in next week, and Jan and I will continue our development on Jinaga.net. See you then.